Okay, well, welcome to the project for chapter 3 video. This is probably going to be a multi-part, so I'm going to go ahead and call this part 1. If you go into your Blackboard and go to assignments, you'll see project 3. It says this project will go further than the requirements listed in the text, which means we're actually going to do a program, and I'm going to help you get started on that. Because we've done all this input-output processing stuff in a different class, CIS150, which is a prerequisite for this class unless you're an engineering student, you kind of already know how to do an algorithm and pseudocode. But I've given it to you nonetheless. I won't do that for everyone, but I have for this one since it's your first real graded project. It says here that the exercise is found, exercise 7 on page 72. So go ahead and open your textbook to page 72, and let's look at the actual requirements of the program, and then we'll look at this algorithm. It says here, Michael wants a program that calculates and displays the percentage of the total points he contributed to his basketball team's final score. Michael will provide the number of 2-point baskets, 3-point baskets, and the number of free throws his team made. He will also provide the same for himself, okay? Because the whole point of this thing is Michael wants to see the percentage of the total points he contributed to his basketball's final score, all right? So they're asking for 3 inputs for the team and 3 for Michael. And it says that on further down. They've given you some test data here, and the algorithm I've given you test data as well. And also, we're going to be doing a percentage. So in order to do that, we have done an algorithm. You always want to do your logical design, which is your algorithm and all that first, so that you understand the problem. Before you start flailing away at the keyboard, this should already be done. And now, since that was a lower level class, I'm not going to be requiring you to send me this, but you need to be doing it. So I only want to see programs. Okay, so let's go back to my little application here. And again, this is, I called it Project 3, and I call the source file Project 3. That's what you should do. If it were 4, you would call your project Project 4 and source file Project 4. This is the little sample stub code from the student resources again that I just pasted in here once I created this empty solution and so forth. So for variables, all right, let's go back to my lecture video. What are variables? They're memory locations where you store and hold data so that your program can do whatever it needs to do. Everything has to have a memory location. Now, let's go here and think about what kind of variables we need. Since we're talking about 2 and 3 and 1, we're talking about integers here as far as these points go. So that's what we should use. We don't need a double because they're just single digit, there's no decimal component. So an integer is any number that's positive or negative without a decimal component. So we're going to use an integer. So I have to use the data type in my declaration. Now, what to name these? According to the algorithm, we got something of a name here, but it's not really a name because it's not camel cased. It's just written out as pseudocode. So let's go ahead and try to give these names. Remember, camel casing, if it's one word, it's all lowercase. If it's more than one word, every subsequent word or name or number is uppercase. So let's see. Team, we get to team first. I'm going to go ahead and do these first. 2-point. Give an initial value of 0, right? Team, 3-point. Initial value of 0. And team, free points. Sounds like 3 points, doesn't it? Points. Give that initial value of 0. All right. So now we need the same thing for Michael. I'm going to go ahead and copy and paste this, try to speed things up a little. I'm not that great of a typist. At least not this morning anyway. Now you can copy and paste this stuff as long as you remember to change everything that needs to be changed. So Michael is the first word. It doesn't matter if it's a name. Right? So I'll change this. So it's lowercase. Whoops. Well, I just messed that all up, didn't I? CHAEL points, free points. There we go. Oh, wow, did I mess this up? All right. Must have hit these stupid touch pads. You can't turn them off on this machine, and it just drives me nuts. I touch it, get a hover over it, and it just goes crazy. I'll blame it on that. Probably my own ignorance. All right. There are 6 initial variables. That gives us, let's go ahead and save this. That gives us 3 for the team and 3 for Michael, which is what the specifications call for. Now, in order to calculate, if you go back and look at the algorithm, in order to calculate the percentage, we have to multiply these values out by their points and calculate a total for both the team and for Michael. All right. And then we're going to have some place to put the contribution or the percentage. So we need more variables. The integer, we can still use an integer for the sum, for the totals. I'm just going to call this team, team score, and set it equal to 0. Now, watch this. I need to tell you about this. This little pop-up window you see here is called IntelliSense. And you'll see that whenever you finish typing a valid name, this will pop up and show you for that object all the methods and properties and functions and so forth that are available through that object. Now, we'll get into that later, but it's more than object-oriented stuff. But still, that's what we're doing right now. So I'll call this Michael score. Now, you come up with these names yourself. They need to be kind of self-documenting. They don't need to be super verbose and long, just long enough for whoever's coming behind you to recognize this. If they see it in code, they know that it's going to be holding somebody's score. So in that way, it kind of self-documents. Okay, now we need one more. I'm going to make this a double because this is going to be the percentage, right? And we know it's going to have a decimal component because of what it says here. And the fact is percentage, it could be like 3.8%. But if you read on down here on page 72, it says round the contribution percentage to 1 decimal place. And it gives you an example. So that needs to be a double or a float. I like using a double. It could be a float. Let's use a double. And we'll call this Michael contrib. Notice I shortened that. There's no sense of writing out contribution. This needs to be 0.0 because it's a double, has a decimal component. All right. So let's go ahead and continue on. So we got that. Now we need to get this input from the user. In order to do that, we're going to have to use a pair of CIN, cout statements. And these come from these using libraries up here, IOStream. So what we want to do is we first have to output something to the screen telling the user what it is the program is expecting. All right, so cout, remember that from the first little thing we did? 2 left pointing chevrons. This is going to be a string literal, so it needs to be in quotes, as you already know. And we'll call this, see, please, whoops. This is sentence caps, so it's just sentence casing. Needs to be, start off with uppercase and readable. Please enter the team's number, what do we call this? 2 points. Number of 2-point baskets. 2-point baskets. Colon space. The reason for the colon space, and this goes way back because these are console apps. They're almost like an old DOS app or mainframe type application as far as the way they look. They're not GUI. You didn't want your cursor waiting on the user to input that whatever it is you're asking for to be setting hard up against this S right here. All right. So because of readability purposes mainly, I mean, it's not as easy to read. So if you put a colon in a space, that cursor will be setting right there, flashing, waiting on their input. So we don't want a new line because we want that cursor to set there, indicating to the user that we're asking them for some data. So now a CIN takes the data from the keyboard or from the stream and places it in a variable that we put in line here, which is team, right? 2-point. And then we can go ahead and do that. And we can do, let's just separate it out a little bit. We'll do a cout and a new line, ENDL, ENDL, just to kind of make it a little easier to read. So I'm going to copy paste this because we're going to have 6 of these because there's 6 items we got to have. And I'm going to go ahead and do the first 3. Okay, please enter the team's 3-point baskets. Now I have to make sure that I use the right variable here or I'm going to have a logic error. It won't give me what I want. I'll be overriding team 2 every time. So now we want free baskets, free point, teams free point, whoops, baskets. All right, now what goes here? This. All right, now I have something that resembles what I need. Let's save it. So the first one asks for the 2 points. It puts it in this variable. Then I do an end line just to separate it out on the display. And then the next one says, cout, please enter the team's 3-point baskets. And then I cin grabs whatever they type and sticks it in this memory location pointed to by the variable name. And another new line. Please enter the team's free point baskets. It sticks it in free points in a new line. All right, so let's go back to the book for just a minute. It talks about rounding to 1 decimal place. Let's go ahead and do this right. Let me show you this real quick, and then we'll get into the processing. You can use a cout statement to round and set the precision of decimals in a number. So it's cout fixed, if I remember correctly, chevron, and then set precision. Notice that it shows up right here. Yeah, I can click on that, hit tab, whatever, and I want to set it to 1 precision. All right, so there is our first part of our program. I'm going to end this part 1 here, and I'll see you in part 2.